It's also a good idea to tighten up on the gibs in the cross feed so that there doesn't come a back and forth motion. If you let the cross slide loose, it has a tendency to work under the stress of the cut. It's a rough casting so that it's not a uniform wall thickness where we're cutting. That's why you can hear the unevenness to the cut. Now the tool has come all the way through, so I can stop the carriage and stop the lathe. I'm going to back this off. It's just packed full of chips in there. You can see the surface inside where the boring tool cut. I made a nice finish. This was only the first cut, and we took a heavy cut. If you want to get on to a smoother surface or a larger size, you advance the tool and carry on with it. I want to show you the tool so you can see the shape of it and the way we adjust it. You see, here is the lathe tool. It's shaped like a round-nosed tool that you would use for turning, but it has to be made short so that it will fit inside the work. And there's a set screw here that I use for adjusting it. If I had wanted to increase the diameter of the bore that I just made, I would have loosened the set screw and pulled this tool bit out a few thousandths of an inch and retightened it and run the bar through a second time. In any event, it's the most accurate form of boring that you can do on a lathe. This is the way that I prefer for machining the cylinders for engines in particular. There's one operation that you can do on a lathe that provides a great deal of accuracy, and that's a grinding operation. Now, grinding operations are messy operations because they throw a lot of abrasive particles around, and whenever you're grinding, you want to be sure to put the things over your lathe bed to protect it. The tool that I have mounted on the compound rest here is a little tool post grinder, which was made in the shop here. It carries a stone on this end. The stone rotates in this direction. I can change the stones to different diameters. I can change to little small ones. But the purpose of using this grinder is to take any hardened surface and grind it away so that you leave it with great accuracy. Now the center points that are used in a lathe are hardened, so these are good subjects to use for grinding. They don't have to be the pointed shapes. You can grind along cylinders, or with little tiny stones you could reach inside and grind on the inside. There are a whole lot of things that you can do. But for the purposes of the demonstration, I'm going to show you how I grind a center point. I've taken a number 2 Morse taper center point, which would fit the tailstock, and I've put it in a sleeve so that it fits into the headstock, which is a number 3 Morse taper. Now the included angle on the point of a center is always 60 degrees. So in order to accomplish a 60 degrees, I'm going to turn the compound slide to a 30-degree angle, which I can check from the protractor on the bottom, or I could use an indicator to indicate it into a very accurate surface. The stone rotates in this direction. I want the lathe to rotate in the opposite direction because I want the work on the lathe to go in this direction past the stone, which is coming in this direction. We want them to be rotating against one another. And we take a very light feed and we use the compound rest handle to move it back and forth. Now I'm going to clamp that into position and show you how I do that. I've got the compound rest turned to a 30-degree angle, and I'm going to lock the screws that hold it in that position. You see, this little tool post grinder has its own motor built into it. It's belt driven down to the spindle, which carries the stone. Now as I bring this forward, I have to feed the compound slide in. I have to feed the cross slide in. And then I have to come forward with it, because I have to get it in a position where it will just clear the surface of the center point. Now I'm placing a towel so that the hard abrasive particles from the grinding don't get onto the lathe any more than I can help it. Now as I bring this back, the stone will be brought into contact with the point. I'm checking the travel to make sure that it covers the full length of it, and it does. Now I'm going to run the lathe backwards so the spindle turns in that direction, because the grinder will be turning in this direction. Okay, shut down while I start her up. Now this center point was in quite good condition before we started, so it took very little grinding of the surface to bring it back to a really good surface. It's accurate now, it will hold work very well, and it has a good running surface on it. The grinding can be applied to anything where you want very fine accuracy. Usually you grind on hardened steel is where you get the very best results. It can be used, for instance, in grinding valves or in grinding the stems of hardened valve pushers, that type of thing, where you can get a very precise control of the diameter and you get a very good surface and you can produce very accurate work, which has been the theme of what we've talked about today, to try to set your lathe so that everything you do will contribute to accurate work. And just bear in mind that the work that you produce on your lathe can certainly exceed the accuracy that the manufacturer put into the lathe if you apply the principles that we use today and work carefully. And I think that you'll find, as you apply logic to each lathe job and think it through and apply the principles, you're going to find that you enjoy your lathe work even more than you do right now, because you'll see the fruits of it in getting finer work and better fitting pieces.